My name is Farhan Mashaki. I go by Frank Match on Planet MySQL and in the community. As you can guess, my voice is really bad right now, so just bear with me as we go through all this. I want to cover a lot in this presentation just because when it comes to really optimizing MySQL, a lot of it really depends on the application design and what you're doing. I mean, there's so much you can do with InnoDB and the operating system, but as you will see, I will try to really go over as many things as possible and trying to give you the best amount of stuff that I can give within this short period of time. So, I will cover something about, I'll tell you a little bit about code log, some things about architecture, a little bit we'll go over schema optimization really quick, how you can optimize Sun and Solaris for your particular workload needs, and then within that I will give you an overview of chip multiprocessing and chip multi-threading, two technologies that I see you can get a benefit from using Sun hardware, and then we will somewhere cover InnoDB as well. How many of you have actually heard of code log before coming in here? We make a joke, it's the largest website that no one has heard of. Because we are very big in South America and Europe. Particularly we are like the #1 website in Chile, #3 website in Argentina. And at this point, we have like 16 million members, almost 500 million photos. The interesting thing about that is that we only allow people to upload one photo a day. So in one sense it's a limit, in another sense it's a great magnet that keeps our members coming back and back. At this point we have almost 1 billion, a little bit more than 1 billion relationships within our members, and we get 10 million comments a day. And last year actually there was a great big student strike in Chile that was all organized on code log to protest against rising educational costs, and media and government agencies were actually communicating on code log to get that strike resolved. That's when I joined code log, 2006. And we were doing 30 million page views. And during my interview, one of the things I was told was that yesterday we had some database issues. And it kind of helped in my favor because I got hired. And today we have actually crossed 150 million page views. And in doing so, we haven't really added a lot into our core cluster as far as database servers go. What we did was really focus on all aspects of optimization, all aspects of application design, and most of our scalability on database end came from adding memory and optimizing things. This is just a quick graph to give you an idea of where how many page views we do as compared to Flickr and Wikipedia. And as you can see, we are going quite high number of page views. So, one thing I would start with was this question that I actually asked in my interviews. The reason being that there's not really an answer to this question, but it just gives me a very good sense of what the candidate's point of view of I/O is. And one of the answers I got was this. The best I/O, I would have to say keyboard is the best I/O. What I was looking for was an answer like best I/O is no I/O. Because really if you are dependent on your disk to serve data, you are not getting as much throughput as you would like to. There's always more room for improvement if your disks are heavily involved. So I don't have the copyright for that, but I did put I will write my own queries here. because one of the things is that when people use frameworks, they outsource a lot of query writing functionality to framework. And as has happened in our case again and again, that we optimize one thing for one query, and as we migrated to Java, some of the queries automatically got like rewritten in that sense. So, and they caused us a lot of issues because just because someone changed the sort of select from, etc., order by. We used to have a column called posted. Someone changed it to identifier, and it went uncaught for like 4 months. And that spoiled all the optimization we had done during that period of time. And why did it went unnoticed? Because no one wrote that query. In other words, in our case, that query was just, it was my understanding that it was rewritten as part of the framework. Data modeling is something so important that if you really focus on it, you can get an incredible amount of scalability and performance from it, as far as scaling up is concerned for your servers from it. It's something that you really cannot ignore, and if you, the benefit you will get by spending a little bit of time in there is going to outweigh like all of the things you can do. So green schemas is something I wanted to say because I think green schemas are the schemas that get the job done with the least number of I/O requests. So the focus needs to be the cost of I/O, not the time it takes for the queries to return. Very quick note I will do on schema optimization. If you are using auto increment in InnoDB, you have a very big scalability limit right there because it has table locks involved in it. A better thing is to use sequences, use application-generated IDs, because so you won't get into table locks when writes are happening, so you can benefit from concurrent insert. Char versus varchar. This is something that again gets into char will give you probably better support on the disk, but varchar is something for InnoDB that you really want to go with to save space. Int versus big int. I've seen so many times that a schema would have big int as the primary key or big int as the columns, when the reality is that int alone will give you 4 billion, like a very big range. So unless you really need it, you're wasting 4 more bytes trying to use big int versus int. Because int would take 4, big int would take 8 bytes. Same with timestamp versus date time. If you really don't need to, if your column is just going to store values up to 2037 or so, you can stick with timestamp, say 4 bytes per row. One thing with InnoDB is that really kind of hurts people is storing text as a column in InnoDB. The problem is InnoDB allocates 16 kilobyte data page. InnoDB keeps the text part, stores it off data page, so it's not stored on the same data page. And because of that, there are some additional lookups involved, and it reserves, I believe, 16 kilobytes for it, so there is like a lot of space wastage concerned over there. However, there will be times when you will have one thing more available than the other. In my case, we could not re-architect right away. We couldn't really add a lot of servers right away. But one thing we had was a lot of disk. So we did a compromise going with letting InnoDB waste some table space so we can continue processing queries as efficiently as possible. The other thing that really is a myth, I think, that bloated primary keys in InnoDB waste a lot of storage. It does, but however, it's not really that scale. If you have proper primary keys, all your data is going to be clustered by them. And once it is, you will be able to, especially for foreign key-based lookups, you're going to be able to process the query with the least amount of I/O costs involved. Locking granularity is something that, of course, has to be the big focus. This is one of the biggest bottlenecks that you will feel if everything else is fine. Auto-increment will give you the right bottleneck, right table locks in InnoDB, but other than that, you should be okay with InnoDB. And yes, auto-inc table locking really is that bad. It has been like one of the biggest pain for us, and now we are in the process of finding a way from it. The other thing is not just disk-based read-write-spin locks, but you also need to focus on what's the intention in memory for memory locks. So for instance, one of the things I've seen is query cache being used without being justified. So if you don't really have a very high query cache ratio, you can use one Solaris P-lock stack, and in a high read environment, you will see that there are a dangerous number of requests waiting for memory lock to acquire memory lock. So it's like sometimes if you're not especially if it's not justified, the cost to maintain query cache is extremely high. So you're better off outsourcing that feature to memcache and not relying on query cache at all. Clustered indexes, as I said before, I think one of the most overlooked features, not only by DBAs, not only by developers, but also by, I think, storage engine developers. One of the things I'm very disappointed is all the new storage engines, none of the storage engines have even on the roadmap clustered indexes. But clustered indexes is something that really makes a lot of sense. If you ever have to do foreign key-based lookups, you really have no other choice than to go with this, or you are wasting your I/O budget. InnoDB thread concurrency. This is where we found the competitive advantage in using Sun servers. Why? Because when we started out, we started with like 8 InnoDB concurrent threads. Very quickly we found out that we had a lot of transactions waiting to join the queue. Whenever you run show engine InnoDB status and you find that a lot of transactions in there say waiting to join the queue, that is a signal to you that you probably need to increase the InnoDB thread concurrency. So you probably keep increasing it until one of the two things happen. The server crashes or you stop seeing those messages. But this is ideally done in a benchmarking environment. You can see if your server can really handle it. We have found that even UltraSpark, Niagara 1 chip, being able to handle 64 concurrent threads in the 2 CPUs. And one big assault I would like to present is only run high number of concurrent threads if your queries are incredibly efficient. If you are running like range scans, or if you are running like group by or some complicated SQL, then 64 threads will really be done. The other thing is when you should look into modifying InnoDB data page size. Currently, by default, it's 16 kilobytes, and generally you don't need to play with it. However, if you are in a very high write OLTP environment, that it may help you to actually decrease it. If you are in a high read OLAP environment, you may want to investigate whether increasing this can help you, because all this can lead to less fragmentation on the drive. InnoDB's read-ahead gotchas, this is something that most people overlook. What happens is there is a sequential read-ahead algorithm in InnoDB, and there is a random read-ahead algorithm in InnoDB. And what happens is, for instance, if InnoDB sees that you have accessed 13 out of 64, so a segment in an extended InnoDB will consist of 64 pages, each 16 kilobytes. So if InnoDB sees that you have accessed 13 of those data pages in sequential order, it will start putting read-ahead, advanced read-ahead requests. The problem is, suppose you are using clustered indexes and you have just read the first 13 pages, data pages from this. Now, that's all probably you need. However, InnoDB will now think that, oh, you probably need to remain another 1 megabyte of data to be read, and it's going to immediately schedule that. Although it has just scheduled it, and it hasn't actually started reading it yet, let's say another query comes in, and it actually needs to read something different. InnoDB cannot cancel the scheduled read-aheads. So all the queries will then waiting for this read-ahead to happen while everyone else is waiting. So this can be really problematic for, we have actually started seeing this happening to us where every time I check, it's like InnoDB is busy in reading ahead, even though we don't need that yet. The problem is intensified if you use SAN and your SAN actually has speculative prefetching enabled, because now you are reading ahead at 2 levels. And this is one of the places where I would like to say for really high volume environments, if you see that this is becoming a problem, one thing you may want to do is go against the traditional wisdom and not disable file system caching even for InnoDB. And the reason for that being that generally it's said that don't use file system caching when you are using InnoDB, because InnoDB has its own implementation of cache. But the problem is when you run into read ahead issues, then like when you get into the read ahead issues, then it helps you to actually have allocated some memory for file system caching so that all those advanced read aheads can actually utilize the file system cache. But this is something that you need to benchmark. I'm about to turn, Hiki actually just told me that you can, the easier way is to just disable read ahead algorithm by setting the threshold really high in the code. Because modifications to really make it optimized will take a lot of time. And the biggest issue will be that scheduled but not yet started cannot be stopped. So there is like, even the scheduler for read ahead is not optimized. You can by the way check that, show engine InnoDB status. If you see pending normal AIO reads, if it's 256, then you should probably look more into it because you are probably getting this. Other important options are, I won't go into detail over there, but auto-implement block mode, you can read all about that in that URL. Basically now with 5.1 there are options where you can have a less taxing auto-implement and that won't involve table locking. Buffer pool size, you want to set it as high as possible, but know that in certain cases Linux and Solaris kernels can actually start putting more importance on file system cache. So even though you have memory available, the kernel will actually start paging MySQL, like swapping MySQL, just so because it considers file system cache more important to maintain. So that's something that we need to watch out for. Slash project transaction commit, if you can use some data out to 1 second. If that will be okay, go with it. However, keep that in mind that you will need in case you will lose some data in case of cache. InnoDB flush method is help to bypass the file system cache when the flush happens. And this is just to go ahead and flush it directly to the devices. There's another one I will get to it in post-IO, which will actually be more improvement as far as Solaris is concerned because of how Solaris does read and writes. Log files look is something also important. So generally, if for very high environments, for a very high environment, you want to have like not just 2 log files. This is a general wisdom. Because what happens is, as you fill those 2 log files, it goes back and starts filling the first one everything. So having 3 in high-write environments is going to eliminate, is going to reduce the amount that it has to go back and start recycling the logs. Thread cache and table cache size very important. Basically, keep monitoring them with show status. And if you see them increasing, you basically want to increase the number of these variables. If you see like threads created has increased a lot, then you should keep increasing the cache until the threads created number stops increasing. One more thing. When InnoDB's buffer pool gets filled, then what happens is that InnoDB has to make space within that, the memory allocated for buffer pool. That is a costly operation. And I was one day sitting with Jeremy Cole, and he actually was working on this problem. And that's how I came to know about it, because I have not benchmarked it, but he has a patch for it. If you contact him, he will be happy to give it to you. One thing I just want to say very quick, dtrace is your friend in Solaris. Don't use Trace. Trace is very expensive. Dtrace is much less costly in terms of trying to monitor. I wouldn't go in dtrace because there is it will just take too much. But what I would say is Brendan Gregg is the person whose name you need to know. And if you search for Solaris internal, there's an excellent set of toolkits available, ranging from IOSnoop, ranging from SeekSize. Like, all these will give you incredible insight into what exactly MySQL is doing, how many files it's opening, how many logs it's doing, what's going on, and what's the SeekSize, whether it's random I/O happening, whether sequential I/O is happening. Large dose Kafka, you should, one or two of them you should have always on. Kafka is something really important, so you can keep track of how your I/O and everything is going. Know that if you ever see your wait time, or you see your disk is busy more than 90% of the time, is reported as 75% busy, 90% of the time, you are I/O bound. If you're using SANs, all these need to be taken with a big grain of salt, because in SAN environment or storage arrays environment, the statistics provided by SAN are going to be much more accurate than IOStat. With IOStat, if you're still using it, what you need to do is focus more on reads per second that are happening, kilobytes per second that's happening, and the average service time. Everything else, there's a lot of thought in there. Benchmark. Very quick note on that. Benchmark carefully. Don't rely on anything that the salespeople tell you. SysBench is an awesome tool, but don't rely on it for your production benchmark. I have been burned by it many times. What you need to do is actually do your own production benchmarks. That's what I found very easy. The best way to do it is take queries from the store query log or generate IDs from your database, then simply write a script that plugs those IDs into your production queries. Take a database, put it on the server, and just run it. As you're running it, make sure you run IOStat, preferably the X and Z option, and then log all the output to a text file to see exactly how I/O played out. I/O-based benchmarking is what I find to be more useful than seeing how much quickly it got done. SuperSmack, a lot of books mention it. On Solaris, you will waste months trying to install it, and probably it's not going to end up working, so don't even bother. And then even if you do get it installed, it's really complicated. It's not worth it. So your own thing will actually help you get a lot of insight into it. Benchmark maintenance queries. That's something that's ignored. And for instance, if you are benchmarking a server, make sure you benchmark it in multi-threaded environment, but also make sure you benchmark single-threaded operations. How does an alter table happen? How would you repair a table like that? What's the time reward with that? And as we go further down, I will tell you more why that's important. Generally bypass to query cache, outsource it to memcache as much as possible. You may also want to think of, if you have file system cache issues in an NFS environment, you may also want to think of using memcache as your file system cache. What an interesting thing FlowCloud does is we use a kind of a deterministic cache and a non-deterministic cache. Deterministic, we say where we expect data to be there. If it's not, it's gone. Non-deterministic is the classic memcache model. You select from database and just plug it in memcache and go. Bypass file system caching, as I said, with or direct or force direct. With force direct I/O, one of the things is that you should read about it more. What happens is if you mount volumes with force direct I/O, it kind of gets Solaris kernel as signal, and it can much better efficiently schedule your I/O threads. And it doesn't actually have to get out of the kernel to do I/O, but the I/O can happen from within the kernel. Segmap percent increase, that is a very important variable in ETC system file. What that does is that allocates the percentage of memory that Solaris can use for file system caching. If you are MySQL based, you really need this to be high. The default is 12%. So based on your memory, you can set it to like 50%, whatever. It won't reserve memory. It will only use it if it's reserved. Other ETC systems, there are like, I think I should have here. Yeah, so some of these are, don't take the values that are here, but these are some of the things that must be in the ETC system file. I will leave the task on you on reading about each of them, figuring out which one would apply and what do you have available. In other words, this is like rational parallel memory. So this is all based on your workload. It can differ dramatically from one system to another. So all these numbers are just like not even like recommended numbers. So this is just like, it may, if you put exactly as it may work great on this server, but it may not. So this is where you will be clear. But these need to be present in your ETC system file. Sorry, I need to do this. It doesn't help us your voice is back. Voice is gone and your throat is getting dry. Okay, now partitioning. One of the most important things in scalability. If you take this wrong decision, if you do it wrong, you will have to re-architect at some point. Investing time earlier is better than having to re-architect. I have not heard of a major website that hasn't had to architect at some point. Now, the good thing is that there are best practices available where you can implement those best practices right from the start and not have to worry about re-architecting at every point. Function-based partitioning is what we use at FlowCloud. Basically, a certain function is in this cluster, another function is in this cluster, and within those clusters, you will have partitioning implemented. Table partitioning is also very important. There are, like MySQL 5.1 supports table partitioning. However, that table partitioning leads to hotspots and cold spots. So if you partition based on, for instance, your what I would call your foreign key-based ID. So the benefit to you will be that even though you're partitioning, each of your partition tables can still continue growing versus stopping at some point. So application level is something that would really help you if you implement it. Directory server approach, there is HiveDB framework that has been developed by Cathepest and Boolean scaling, Agile code, etc. And what it does is it kind of, even if you don't implement it right away, although it's readily pluggable in Java, it will give you a lot of best practices on how partitioning should happen, and you will never need to partition again. You can just keep adding servers and it will keep working. Connection pooling is something that is very important. It helps you, but it doesn't help you. It helps you scale, but it doesn't help you scale. So it's like, it all depends on how it's implemented. If it's efficient, you're good to go. If it's not efficient, it's not. So if you find this depends on your particular workload, but if you find that your connection pooling is not optimized, maybe that will be a time to rewrite your connection pool. And if you do rewrite your connection pool, you can implement all the best practices of HiveDB and the partitioning thing I mentioned earlier into your connection pooling layer. Basically, make your connection pooling decide your re-architectures or partitioning strategy. So that way you don't have to add another layer to be able to partition. You can always, when you ask the connection pooling, hey, give me a connection for user friend, it can apply back to you one of the two ways. It can either apply back to you with the actual JDBC connection that you can now immediately connect to, or it can apply back a string saying friend database 20. So you can now then connect to database 20 knowing that my data is located there. Then the other thing is in connection pooling, you can write all your re-architecture rules. Partitioning all re-architecture rules. So if you already are thinking of re-architecting, you can start building those rules in connection pooling. That way you can almost support two parallel architectures while you do migration. C3PO is what we used with Hibernate, and the problem was that you specify all the criteria based on a database, not database server. So if you have a server which is represented here with the square, then you are basically allocating connection, and all the settings that you are doing are being allocated on a per database level. So for instance, in this case, let's assume that we have 30 connections, each arrow, let's say, represents 10 connections, open to database on blue database, and 30 open to the red database. And let's say blue database connections are doing nothing, but red database is actually doing work. And now let's say you need another 10 connections, but let's say 30 was the maximum you set. So now you will start getting too many connections error, even though the other blue connections are also going to the same database. So you will start having, like, your users will start experiencing issues. But an ideal thing would be to have connection pooling that works like this. So in other words, you set up for a database server, not for individual databases on that server, especially if you have multiple databases. This is where the connection pooling thing that I just explained will come in. App server asks connection pooling there, there's the user is there, you hit right to the database, and scaling connection pooling there in that instance will be an issue if your scheme is dependent on that. Yeah. Okay. We don't have DRBD in Sun, in Solaris. It's only for Linux. So two approaches to high availability would be: one, go with master-master application, so you can perform alters on one table while the other master is handling traffic. However, then you have to switch the role and wait for the other master to catch up before you can run alter on that table. Intentionally kept behind stage for disaster is something that also you should look into. So if someone does actually drop a table, you can run to the other slave and save it. Solaris clusters is, I just learned about it yesterday. It seems to be a replacement for DRBD, high availability file system replication. So this, I just took the definition from the website and put it here, but if you want to look into it, I've posted the URL right there. Hardware and architecture is something I really want to discuss, because I think that Sun is doing an excellent, they're not doing anything but this. Sun is doing an excellent job in its new architectures. And if you pick the right architecture for the right task, you can experience a lot of results that are not available in other architectures. And I will show you why. Actually, let's get to this slide a little later. So, generally, this is how your, or most, like, new brand new servers work that are not specialized. Like, in other words, if you are just merely buying x86 or NVMe processors, they are basically focused on chip multiprocessing. And how it works is like this. So while you're looking at it, I will tell you that after disk, the biggest bottleneck you have that is ignored by a lot of people is memory latency. While you people are really quoting a lot, increasing memory size, the memory speed is not increasing as much. So a lot of bottleneck still remains in this kind of architecture. So chip multiprocessing, you have, for instance, n cores per process, in this case 4, and what you see is each core can compute only one thing, and because my skill isn't like really multi-process in that sense, so you're going to compute, you're going to wait for memory latency. Compute, wait for memory latency. And computations are going to go really fast. Memory latency is then going to end up becoming like with chip multiprocessing. This is what chip multithreading does. And this is, I have just represented one core. So ultra-spark T2s. Niagara 2 chip now has 8 cores. So in order to see the whole system, you will put this 8 times. What happens is, if I can follow them up. So what happens is, the cool thing about this architecture is that this is the only architecture I know of that within one CPU cycle can switch 2 threads, which I haven't found in x86 or NVIDIA. Someone does think that they are correct. But what happens is, so you will have right here, these 2 computations will start within a core. So 2 parallel threads can execute within each core with the Niagara 2 chip. So as those 2 will start, and as we start waiting for the memory latency, the other core switches within the same CPU cycle and it executes computation for that. And then, so it's like goes like 2 at any time. And as this memory latency rate is finished, the next one is ready to go right there. These 2 will just click on right there. So one thing about this architecture is Sun has made it so it's really focused on those applications that need to run multiple threads and operate on a large shared buffer memory pool. So this architecture is designed for that. What happens is that you end up getting 64 hardware threads with it, but don't allocate your databases based on hardware, based on CPU power. If you have really large OLAP environment or even OLTP environment, you're better off allocating based on memory and ignoring the benefit you have with CPUs. Then you will waste CPU power, but that will come into redshift and blueshift architecture. Basically, if your applications are growing faster than the Moore's law, then you need to not consolidate. You need not to go in containers. You need to let it grow and have as much data go through your memory as possible. Versus allocating based on, so for instance, T2 architecture comes with 32 gig of RAM. Now if you put 4 database instances on it, then you can only give 8 gigabytes on each. So that becomes a problem situation. Better thing would be, if you have really large databases residing on it, let it have a bunch of memory as much as you can give it. So I would like to have a lot of questions, so I want to hop right there. And this is my blog, because that's the
yeah, so you mentioned before about with InnoDB, sometimes it goes into squabble when it shouldn't. I'm wondering how you dealt with that. Is it just with direct idle correct?
Yeah, it's not just InnoDB. It's like an issue of kernels.
So does it not happen on Solaris then?
It does.
Okay.
It does happen. Well, there's a setting on Linux. There's a setting called proxy something swappiness.
Yeah.
And there's a similar setting in Solaris, but
I said it's 0 and it's still held in swap.
Oh, really?
Yeah.
So that was my understanding that it would bypass it. But in our case, I actually didn't put that particular setting in there. But it is, if you search for Solaris10 swappiness, you should be able to find that setting and how to turn it off. But the problem is just that at some point kernel thinks it is more important to give memory to file system cache than it should for database. This is like really doesn't make sense. Yes, please.
Yes. Have you found that the reason you're not using active so many processors is because there are locking problems in the code?
Yes, so the locking, InnoDB's locking implementation is pretty fast. The only way it really becomes a problem is auto-increment locking, and actually there's a session coming on by Mark Ellerman, and he is going to approve it, and I think it's probably the next session, and he's going to talk about how you can make InnoDB use more of the codes that are available on the server. So I myself will go there and try to see what he has to say. Yes, please?
Two questions. One is a follow-up of the swapping problem. I know that some applications are running Solaris where you can put Solaris to lock the memory for the so in every case you cannot do that in the SQL. And the second question is the D2000 system is better for many 32 databases that one 64 that is the whole memory.
You mean 64-bit?
Yes.
Yeah, so the first part would be that, yes, you can, I think, lock memory and say, but however, there are some serious concerns in there as well. Basically, if you lock memory, I think it locks you can lock swapping, but if you are using any kind of file system, unless you have totally disabled file system caching as well, then there will be a time when you will run out of memory and kernel will not swap. So you can have a somewhat of a disaster over there. And the second question about using 32-bit and 64-bit, go with 64-bit unless you really need to stick with 32-bit. The issue primarily is that 32-bit address space is limited to 4 billion units. So what it translates is that you can only use 4 gig of RAM for a 32-bit binary. However, if you use 64-bit, you don't have that limitation. But if you use my ISOM's there's a cache for the window in my ISOM. Yeah, the shared cache is my ISOM. I can't right now. It's anyway. Similar where you have like my InnoDB buffer pool. There's a similar. I can't remember it. But sorry. Yeah. There you go. The key buffer size. Thank you very much. So key buffer size in my ISOM is 32-bit, even if you're using 64-bit binaries. So the way to overcome that is you can physically create multiple key caches and then load them, and then you have to put that in your startup script. So every time my system starts up, it can recreate those caches, and each cache should still be 4 gig. But process limitation comes down to I think 2.7 gig for 32-bit binaries. Yes, please.
First one comment was about the G2 processor 64 gigabytes, not just
really, the maximum on that 64?
Yeah, the G2 the 64 bytes is 64 gigabytes.
Okay, thanks for correcting because we. Sure.
So I'm wondering if you had any thoughts on using InnoDB, but have you considered
So the biggest headache we have is that none of these new storage engines can even satisfy me on paper. Like, so if they don't satisfy me on paper, I can't go and implement. Basically, I talked to Monty and I said, how can it be that you are completely ignoring cluster indexes? I think that would end up being the competitive advantage of people who would see what cluster indexes offer, because it's really kind of a no-brainer in that sense. So there are issues with cluster indexes. Right now, what InnoDB does is when the fill factor of the page drops below half, so InnoDB has like 16 segments. Within that, it figures that half of them are still free, the InnoDB will try to compact your table space by by analyzing the immediate next page and previous data page. However, for properly implemented cluster keys, that does not compact. So ideally, what InnoDB should do is, for this data page, it should look 10 or 20 in forward direction, 10 or 20 in previous direction, and see by combining all of them if it can save space. So, there's another question to this?
Yeah, you were talking about the prefetching in InnoDB or the read ahead. How can you tell if that happened?
Okay, so if you show engine InnoDB status, then among all the rights releases, they will be pending normal advanced IO reads, like AIO reads.
AIO?
Yeah, so if you see 256 in there, that generally is an indication that right now InnoDB has scheduled a full 1 megabyte read ahead of the, but it's triggered based on this, I can't remember when the random read ahead is triggered, but sequential is triggered after you access 13 out of 64 data pages in that order.
Okay, and you mentioned that it's possible to turn it off if you see that it's already performing.
You'll have to compile it. I asked,
compile time.
yeah, so what I just requested Ahiki was if he could, like, in the next version, make that setting that we can set through my.cnf to set that threshold. But right now, there's like, if you go to the code, you'll find the threshold being set to 13. If you set it to really high, like for instance 64, or even like, I haven't tested it, but I don't know how it would work if you set it to 65. So,
okay.
I never hit that. Any question? Yes, please.
Is there do you have the side-by-side file system performance comparison between EXT and ZFS?
So we haven't used ZFS, but EXT3 I will guide you through Dayton Batisha's blog. He has some it's mysqldba.blogspot.com. In that he talks about some weird things that he was having to do where he would have to recopy a table space because of the fragmentation issues in EXT3. So if you're using EXT3, you may want to copy, and I think he was solving it just by copying it again, and it will solve the fragmentation issues. It goes over my head. We don't use EXT3, so I'm much more fast. But ZFS wise, all our databases are currently UFS. And that's where actually direct IO. Another thing we should look into is concurrent direct IO for UFS. There's a difference in direct IO and concurrent direct IO, and you will find a lot of information on that. And actually Oracle uses that heavily. So if properly implemented, it can give you a lot of benefits.
So did you use a volume manager?
Sorry?
Did you use a volume manager to your approach, or you just...
You need to for snapshots.
Yeah.
Yeah, what we do is we implement snapshots, and actually that has been one of the biggest headaches for us for implementing backups, because we have such a high write environment that the moment we play snapshots, immediately the backup store files start increasing, and before we know it, it goes into like multiple, like hundreds of gigabytes. So what happens is, like, it takes us more time to copy it over, and we were experiencing a lot of problems with that. So what now we are doing is working with a SAN provider to implement all kinds of snapshots at the SAN level versus the operating system level. Last question, please.
The photos themselves, you just put them in the file system?
Yes, photos. And I actually wrote a post on, if you search my name and say, I will not blog, which is like storing media, and I will give you the non-technical reasons why it does not make sense to ever put blogs in database for a very high volume, just because of issues associated with administration, issues associated with resetting the application, issues associated with disaster recovery, and the fact that if you put it in as a blog, you are moving from a platform-independent file format to a platform-dependent file format. So all those can really end up being a major pain for you in the future if you use blog. So it's something, however, there's excellent work being done by Paul McCalla of PBXT in blog region, and I hope he will be able to address some of the concerns with Mr. Roy. I think we are out of time. Thank you so much. If you have questions,